Welcome to the Bits of Good Bootcamp. In this video, we're going to be talking about lifting state up in React. So in general, I want to outline the problem here. And so this occurs when we have several components that need to use the same piece of changing state. And in general, the solution is that we want to lift up that piece of shared state that multiple components are relying upon to their closest common ancestor. It's pretty simple here when I write it out like this, but it's actually quite complicated, so get ready, we're going to go through this. Alright, so for this example, to illustrate lifting up state, what we're going to be doing is building like a temperature calculator with the end goal of telling us whether or not water would be boiling at any given temperature. So you see here, this is going to be our first component that we'll be using, boiling verdict. And boiling verdict is just going to take in some props, in this case props.celsius, and then it's going to use that to display a message about whether or not water would boil. Just kind of a disclaimer, there's going to be a lot of components that we're working with in this video, so if you want to maybe make a special effort to keep track of all the components and especially the relationship between them, what you can do this either by kind of taking some notes, jotting it down on the side, or just paying a lot of attention. You won't get as much out of this video if you're not paying attention to how these components are relating to each other. Alright, with that being said, let's keep on going. So this is going to be our top level calculator component. This is the highest level component that we're going to be working with. And basically what the calculator component does is it renders an input, and then the result of that input is going to be stored in this.state.temperature. And then the calculator also renders a boiling verdict component, the one we saw on the previous slide, and then it passes boiling verdict a piece of its state, this.state.temperature, and it passes this.state.temperature as a prop to boiling verdict, so that boiling verdict can then tell us whether or not the water would boil at that temperature. So let's check this example out here. This is pretty simple. Let me just pull this aside here so you can see. Okay, so here we have our calculator component, and we have, notice, boiling verdict is a separate component. And so if I type in 30 degrees here, the water would not boil. If I type in 200 degrees, the water would be boiling. So you can see here that essentially all that's happening is we have the input component here, which is just an element here, an HTML form element, and we're making this a controlled component where we're setting the value and providing an onChange handler, and then this input is reflecting a piece of this.state.temperature, and then we are passing this.state.temperature to Celsius, and there's a little bit of tidying up work being done here. They're parsing temperature as a float, and they're creating a separate variable to hold this .state.temperature. But in general, we're just passing a piece of our state to boiling verdict. And as you can see, this is working, and we're able to type in a Celsius value and see whether or not it would be boiling. All right, pretty cool, but I think we can make it more complicated. Let's see. Now, what if we wanted to add a second input? Celsius is great and all, but personally I prefer using Fahrenheit to keep track of temperature. But I want my tool to work for both Celsius and Fahrenheit. And more importantly, I want them to be in sync. If I enter a value in Celsius in the first input, I want my second input, my Fahrenheit input, to properly reflect the temperature with the correct conversion, and most importantly, I want them to be in sync. So they really should be reflecting the same temperature, just in their respective units. And so the first step we're going to do is we're going to extract a component out of calculator, and we're going to call that temperature input. So instead of just having a regular temperature, now we're going to have this specific temperature input component. And we're going to add another prop, and we're going to call that scale. And that's how we're going to determine whether or not it's Celsius or Fahrenheit. So you can see here, let's step through this component. First, notice I have just like this reference object. This is just something I'm going to use for mapping C to Celsius and F to Fahrenheit. And then we have our temperature input, and we have our handle change component, and then this is essentially our event handler, and that's just going to update this.state.temperature. And then we see down here, this is basically this similar, like you should recognize these elements from the original calculator. This is what we're pulling out of the calculator and putting into the new temperature input component. And you can see here, we're just displaying here in text what the scale we're using is, and then we have our regular controlled component. So this is handling this.state.temperature. And now let's take a second here and realize what the calculator looks like now. The calculator got a whole lot simpler there for a second. Now you see that instead of having all the things we had before, we just have these two temperature inputs, and we're passing in the scale for each, respectively, C or F for Celsius and Fahrenheit. And let's just take a look here at the code pen for this. Okay, and this should look pretty similar to what we had before. The biggest difference is now we have two. So we have Celsius and Fahrenheit. So let's give it a try here. All right, I'm typing in 100 for Celsius, and we'll type in 200 for Fahrenheit. And we're seeing that our functionality is actually broken. Like, not only are we not displaying the proper whether or not it's boiling message, the boiling verdict component is not being displayed. And also, these are out of sync. When I edit one of these, the other one is not changing. These are not connected at all. So this is a problem. Like I said, when we update the temperature in one, the other doesn't change. That's problem one. And then problem two is that we can't display boiling verdict because calculator doesn't actually know what the current temperature is because the current temperature is being encapsulated inside of temperature input. So we've kind of broken our tool. We need to take some steps to fix it. So also, I want to take a quick second. I don't want to spend a lot of time on this, but just realize there's going to be some implementation level details here that I'm going to be glossing over. But essentially, it's just some functions to calculate between Celsius and Fahrenheit. But I want to focus on the React stuff, not this tedious stuff. Okay, so back to our temperature input. Essentially, what we need to do to kind of solve our problem is we need to lift state up. And the reason is because right now, temperature input, both of them if you remember the calculator has two temperature inputs, both are individually keeping track of their local state. So they're each individually keeping track of the temperature. And this means that it's impossible for them to be in sync because they're each locally keeping track of the temperature. So like I said, the solution is going to be lifting the state up. So this is a good visualization, I think, of what it means to be keeping components in sync and what I mean by sharing state by lifting state up. And like I said before, the way that we share state is that we're going to move the state up to the closest common ancestor of the components that need it. So we have temperature input and we have temperature input here. These are like our Fahrenheit and our Celsius one. And what we're going to do is instead of them having their own state, we're going to actually move the state up to calculator, and then we're going to pass the temperature down as a prop to temperature input. And so at this point, calculator becomes the source of truth for that piece of the state, the temperature, and both of the temperature inputs are receiving this .props.temperature, which is containing the current temperature of the calculator. And so this is going to go ahead and fix one of our problems. So now, because we're passing state down from calculator, both will be in sync. Both temperature inputs will be displaying the exact same state. So you can see inside their render function, before we had this the constant temperature is this .state.temperature. Now it's going to be coming from this .props.temperature. But we still have an issue here, and that's that even though both temperature inputs are receiving the correct temperature, they aren't able to actually edit the temperature. So if I, as the user, type in a new temperature, there won't be anything to actually make that change because props is read-only, so that isn't going to be responsible for making the change. You can't just modify that directly. And then we also, normally we would call set state to modify a piece of the state, but the state is being held in calculator, so there's no way that temperature input can directly call calculator set state function. So now we have to look at another way of doing things. And the way that we solve this problem in React is essentially by making a component controlled. So this is the same thing that we did for form elements for like inputs and text areas and select inputs. All those things we made controlled components, and that's the same thing we're going to do here. So what we'll do is we'll make temperature input accept both the prop this.props.temperature and this.props.onTemperature change. And both of these are going to be coming from the parent calculator component. And so when the temperature input component wants to update its temperature, what it'll do is it'll call this.props.onTemperature change. So you see here before on temperature change when that input was being modified. So this piece of code is actually coming from the temperature input component. And so before, when a user typed something in the temperature input component inside the input there, it was just going to be modifying a piece of the state that was internal to temperature input. Instead, what we're going to be doing now is we're going to be calling this props function. So it's important to note we're actually passing a function as a prop, similarly to how we did before with form elements controlled components. And so we'll just be calling this.props.onTemperatureChange with the value. And then it's the parent's job, aka calculator, it's calculator's job to implement and pass down this onTemperatureChange so that it'll properly update calculator state. I want to take a second here to make note of this important feature here at the bottom, and that's that there is no special reason why we're calling these props temperature and onTemperatureChange respectively. We could just as easily call them, for example, value and onChange, which is actually a really common convention that a lot of React developers follow. Whenever they're making controlled components, they'll call the value, or they'll use the terms they'll use the terms this.props.value and this.props.onChange. So if you want, you can follow that convention, but it's also just as fair to use temperature and onTemperatureChange as they're a little bit more descriptive of what's actually going on. So now let's look at what our new temperature input component looks like in the full, all of this code together. And so to recap, we've removed the state from temperature input. So temperature input no longer has any internal state, as you can see. And instead, what it's doing is it's reading data from this.props.temperature and this.props.scale. So scale was already happening before, but now what we've added is this temperature. So the temperature that this temperature input component is going to be reflecting is actually coming from its parent. And then finally, when we're having our controlled component here of this input form element, the onChange that we're going to be handling, that event handler, is instead of updating any internal state, it's actually just going to be calling another prop, this.prop.onTemperatureChange. Now let's also take a second here and look at the new calculator 2.0 that we've been developing here. And you see this has become a little bit bigger now than it was before. But what we have is a piece of state inside of calculator to represent the temperature and the current scale. And then we have actually two distinct event handlers here, handle Celsius change and handle Fahrenheit change. And we're going to be passing both of these different event handlers to the different temperature inputs, respective for the Celsius is going to get handle Celsius change, and the Fahrenheit temperature input is going to get handle Fahrenheit change. And then over here, this is some of that implementation details that we skipped earlier of actually converting the temperature to be either Celsius or Fahrenheit, depending on what is going on. But just suffice it to say that both Celsius and Fahrenheit, these things being passed in as the temperature prop, are really just derived from this.state.temperature. Don't let this confuse you. This is just some kind of implementation level details that we don't need to worry about. But now the key takeaway here is that no matter which input you edit, whether it's the temperature input for Celsius or for Fahrenheit, we're actually going to get the same answer. Both inputs will be synced and it will update both properly. So this is going to be really cool. Let's check out the code pen to make sure that what I said is true. Okay, pull this over, and then here we have our calculator component. And so I'm going to type in here 100, and you'll see that actually our temperature for Fahrenheit has updated as well. And if I go ahead and type, say, 150 here, it'll update the temperature for the Celsius. So the reason for this, like we've already mentioned, is because both of these inputs, both of these temperature inputs, are receiving the same temperature, which is being derived from this.state.temperature. And because of that, because we moved the state up, we lifted the state up from temperature input to calculator, now we're able to pass the state down and keep our components in sync. Okay, so I want to go over things like in one more recap here to make sure that everyone is still on the same page. And really this recap is for when you're looking through the slides later without the video. But in general, when we edit an input in temperature input, React is going to call the handle change method. And then the handle change method inside of temperature input is actually going to rely on this.props.onTemperatureChange, which is provided by the parent calculator. So then at that point, we're inside calculator, and then calculator will either call handle Celsius change or handle Fahrenheit change, depending on which temperature input, whether it's the Fahrenheit or the Celsius one. And those event handlers inside of calculator will update calculator state by calling this.setState. by calling this.setState, we'll be telling React that we want to re-render, and that's going to call calculator's render function. And while calculator is re-rendering, the render function will pass to temperature input the new versions of this.state.temperature. And therefore, at the very end, we'll have both temperature inputs and the boiling verdict displaying the new and proper state from the parent calculator. Okay, this is a lot, I know. So let's kind of recap some lessons learned. So really what we learned here is that there should be a single source of truth for any data that changes. And if multiple components need the same piece of state, that we need to lift up that state to their closest common ancestor. And really what this is called is lifting state up, and the methodology that we're following is top-down data flow, because we are moving the state up, we're lifting the state up to the highest common ancestor, and then at that point we're letting the data flow down to the children. And so this is different. Another alternative approach that we're not going to talk about in this video, but is employed by Angular, for example, is the idea of two-way data binding. And just know that this top-down data flow is a lot less buggy, it's a lot less prone to bugs than the two-way data binding approach is. So that's a benefit of using the top-down data flow. And then finally, our last lesson learned here is that if something can be derived from either props or state, it shouldn't be kept in the state. And the idea here is that you just don't want to have duplicated information across your application. There should just be one source of truth for any given piece of data in your application, and that's it. You shouldn't keep copies of the state in multiple places, because that's asking for things to get out of sync. And then finally, one thing that I want to introduce in this video at the very end here is React developer tools. So this is something that we haven't talked about yet, but is super helpful, especially once you start passing state around a lot and you're lifting state up. And so you can see here on the right, there's this GIF of the React developer tools in Chrome already. And note that this is something that you have to download or install. This isn't something that's built into Chrome now. So if you go into Chrome now, you're not going to see this. But you can follow this link or just Google React developer tools and you can set it up. But it's really cool because it allows us to actually inspect our component hierarchy as it appears from our essentially React code. And then you can see the props that are being passed down, and you can even see a component's internal state. So this is a really powerful tool to be able to step up and down the component tree to see where the state is changing, and really when something isn't working on the UI, this allows you to figure out exactly what component is messing up. Alright guys, that's it for today. I know this was a lot. Good job keeping up with everything, and if you have any questions about anything relating lifting state up, go ahead and ask a TA. Thank you.